we're going to find a composite function, the f of g of x, given our f of x, which is right here, x squared plus 2, and our g of x, square root of 3 minus x. And once we find that composite function, we will talk about the domain of that composite function. Okay, so the first thing to do is to realize that we're going to be plugging one of these functions into the other. And in this case, we're plugging the g function into the f function. All right, so first thing I like to do is rewrite my f of g of x, and I'm going to rewrite it like this: the f of g of x. Okay, and that's going to help me realize that I'm plugging the g function into the f function. So let me write down my f function right here. And now, when I plug it in, everywhere where I see an x, which is here and here, I'm going to put in the g of x. So let's go ahead and do that. I'm going to put the g of x in here, and I'm going to put the g of x in here. And now let's substitute for what the g of x is. The g of x is square root of 3 minus x. So square root of 3 minus x. And in here, square root of 3 minus x. Make sure that radical goes all the way. All right, now, on the right side, the square root of 3 minus x squared. Well, that's just going to be 3 minus x. Drop down the plus 2. And then all I have left to do is combine the 3 plus the 2. 3 plus 2 is 5. So I'm going to get negative x, don't forget that negative, plus 5. This is my composite function, the f of g of x. All right, so let's talk about the domain of this composite function. Now, there's two things you need to look at when you're finding the domain. Okay, you need to look at any restrictions that you may have in your composite function that you got, and you also have to look for any restrictions in the function that you're plugging in. Okay, you don't actually need to look for any restrictions here, but we have no restrictions here. Okay, I don't see an x in a denominator, and I don't see an x in a radical, so I don't really have to worry about that anyway. All right, do you see any restrictions in our composite function right here? I do not. This has no restrictions. No restrictions. Remember, your restrictions are going to be if you get a 0 in the denominator or a negative under a radical. Now, what about up here? Yes, there's a radical. Okay, so I do have a restriction up there. I'm going to write it down right here. I'll put it in green. And I know that whatever is underneath, inside of this radical, cannot be negative. So that 3 minus x cannot be negative. And what I'm going to say is that 3 minus x must be greater than or equal to 0. Okay, now this is an equation that I can solve. Once I solve this, I will know what my domain is, and then I'm going to put it in interval notation. So let's go ahead and solve to get this grumpy x all by itself. I'm going to get rid of the 3, so I'll subtract 3 on both sides. All right, these cancel, so I'm going to get negative x is greater than or equal to 0 minus 3 is negative 3. One more step to get this x by itself. I see the negative out front, right? It's like a negative 1. So in order to get rid of that negative 1, which is multiplied times x, I need to divide by a negative. Divide by a negative. Okay, remember, when you divide by a negative, you need to flip the inequality over. Okay, just like the flipping the light switch. So instead of being greater than or equal to, this is going to become less than or equal to. All right, I'm going to move it to the right. It will be less than or equal to. On the left-hand side, I have negative over negative. That's a positive 1x. And that was the left side. And on the right side, I have negative 3 divided by negative 1 is a positive 3. Okay, so this is my domain of the f of g of x. All right, now, in order to put that in interval notation, I'm just going to kind of put it on a number line. I always like to go to a number line first. X is less than or equal to 3, so it's going to be everything less than or equal to 3. So I start shading this way. It never stops. It goes all the way back to negative infinity. And since it is less than or equal to, because I have that line down there, I'm going to use a bracket, which is made of lines. Line, line, line. Okay, so that will go into interval notation as negative infinity, comma 3, one interval. The 3 gets a bracket, like on the graph, and the negative infinity always gets a parenthesis. This is the domain of the f of g of x. Okay, and at this point, I'm going to get rid of this thing that says no restrictions because that was only for that part. It does have a restriction, a composite function.